Alright, we're going to talk about a couple definitions and terminology here to start off. The first one, we need to know how to define a sample, and we needed to know how to define an event. So the first one is the sample space is what we need to define, not the sample space. And we label that as S, is the collection of all possible outcomes. And the next thing we need to identify is called an event. An event is any collection of outcomes. And you could have, so our sample space is S, and here we're going to have some other notation for an event. Denote a single outcome as, and you can use any letter here that you want, but I'm going to use lowercase e sub I or little a sub I and so on. You can use any letter you want here. This just represents if it's just a single outcome. So if you wanted to know the probability of observation 100 occurring at that point, that's what you would label it as there. And we'll get to some examples of what this is doing. And then the other one, general events are labeled with a capital now. So capital E or A or and so on. So this capital E could be the probability of, if you're rolling a die, the probability of rolling an even number. So let's look at an example and expose kind of how and what all this means. Example 1. Suppose you toss a fair die once. And here's part A. List all possible outcomes. Alright, well, let's just list them. A die has 6 options, 1, 2, 3, 4, 5, and 6. So here we didn't do anything except just list all of our outcomes. Now let's actually apply what this sample space means. Determine the sample space. Alright, remember what is denoted as? S. So S is equal to, so what you do is you open up kind of a squiggly bracket like this, and then you list all of your outcomes. And that is our sample space. Let's look at part C. Define the event E, capital E, as rolling an even number. Alright, so all I'm saying is label all the even numbers as E. So here I can say capital E, and it's very similar to sample space. Now I'm just creating a sample of the sample space, and I'll just list the even numbers. And if we wanted to do the odd, I could label it as O if we wanted. O is sometimes bad to use because it can look like 0, but I'll do it here anyways. 1, 3, and 5 if we want to do the odd ones. So that's how we label those types of things. Alright, we'll come back to this in a second. We're going to do an example of finding some probabilities. First, we need to talk about the rules of probabilities. Rules of probabilities. And these are important to know, and we will be using these throughout the semester. I slaughtered probabilities there. Alright, first thing to know for the rules of probabilities: let the probability, I'm going to just write as prob, the probability of an event, we'll call it capital E, be defined as P of E. So, real simple statement here, just writing it down in your notes, just take it as it is. It says the probability of an event, capital E, be defined as P of E. The probability, P means the probability of E occurring. If you think of our previous example, E was rolling an even number. So this would say the probability of rolling an even number. Then, and you may want to watch what I write right here before you write it. Then we say the probability of E, it has to be between two numbers or two probabilities. We say it's between 0 and 1. So this says the probability of E is bigger than 0 and less than 1. So probability of E is between 0 and 1. That's the way I wrote that. That's how you would say it. The probability of E is between 0 and 1. That means it can't be less than 0 and it can't be greater than 1, which makes sense. You can't have a negative probability, and you can't have anything that's 101% probability. It's either 0 or 100 or somewhere in between. All right, and number 2. This one we'll talk about more later on in the semester, but we need to know it right now as well. The sum of all probabilities must equal 1. So what this means is, let's say that is if our sample is, let's say, capital S equals, and earlier for our sample we wrote 1, 2, 3, 4, 5, 6. Here I'm just going to label as E1, E2, and so on. And it could be up to En. So N could be any number here, but as long as it's a finite set here. And think of this as rolling the dice example just a minute ago. This is, earlier this would be 1, 2, 3, 4, 5, 6, and we stopped at 6. This could be anything though here. So this is just put in general terms. Then, so if our sample is that, if sample space is that, then the probability of E1 plus the probability of E2 plus the probability of each one of these has to equal to 1. So the probability of the first event, E1, plus the probability of the second event, and then plus ... and it keeps going all the way to the last event. You add all those together and that equals to 1. Again, think of this as rolling the die example. Let's write this out. Probability of rolling a die, let's say probability roll a 1 plus probability roll a 2 plus probability roll is 3 plus, and then I'm going to just abbreviate probability of 4 plus 5, and then plus the probability of 6. All right, we can do this. The probability of rolling a 1, well, on top is how many we want, which is 1, and then the total number that could happen is 6. Plus the probability of rolling a 2, there's only one of those out of 6 possible. Probability of rolling a 3, there's only one of those out of 6 possible. Plus the probability of rolling a 4, 1 out of 6. Probability of 5, there's only one of those out of 6 outcomes. And then last is the probability of 6. So you add all these together. Since you have a common denominator, you just add the tops. 1, 2, 3, 4, 5, 6, which is 1. So that shows you the probability of rolling a die. And I probably should have denoted that. That's the outcomes of rolling a die. But that's what we're looking for right there when we're talking about the rules of probabilities. These two are important to know, and we will be using these throughout the semester. All right, let's look at an example. Let's say rolling a fair die, and let's say part A. The probability, and I'm just going to label right as prob, rolling a 2. Alright, we know how to do this, but I just want to write it out one time so that way we can see some things here. So the probability of rolling a 2, we start out by saying the probability rolling a 2 is equal to the total number that we want, which is only one of those possible out of 6. And that's all we do there. So what happens though is we want to condense rolling a 2. We don't want to have to write this all the time. So we want to do some shorthand. So let's look at part B. Let's probability rolling an even number. So now we don't want to take too long. We don't want to sit here and write the probability of rolling a 2 plus the probability of rolling a 4 plus the probability of rolling a 6. So the way to make that a little simpler, handwriting wise, we call an event. So I'll call this event E since we're dealing with even numbers, but I could have used A or C or D or whatever I wanted. So what I'm saying, this event capital E is equal to 2, 4, 6. So now I've labeled an event and I said E, capital E, is the probability of rolling an even number. So now I can say the probability of capital E, which is the probability of rolling an even number. The probability of rolling an even number is equal to, let's do it. There's our divide sign. On top is how many observations we want or that we're looking for. And here it's 1, 2, 3 observations out of the total number of observations, 6, which is equal to 1/2. So this is what we're going to start looking to do, is labeling events such as this as E. Let's look at another example. Example 2. You have a bag of 7 marbles. 3 are white, 2 red, 2 blue. And find, and we're going to do part A and B here. Find the probability of drawing a red So first off, what we can do here is, since we know we have 3 different colors and we don't want to have to write P, the probability of drawing a red, we just come over here to the side and we can say W is equal to the probability of drawing white. And then we can say R is equal to probability, I'm just going to say prob of red, and then capital B is equal to prob of blue. So now when I come over here and work A, B, C, D, E, F, or however many examples I'm going to do, all I have to do is write this letter, and that tells me the probability that I'm finding. So probability of drawing a red. So all I have to do is write P of R like this. Probability of drawing a red. So I know I'll have a divide sign, and there's 2 reds out of total 7. Simple as that. Try one more. Probability drawing a white. So we just say P of W, the probability of drawing a white, which is 3 out of 7. All right, let's look at this one. Probability drawing a red or blue. So here we can say the probability of R plus the probability of B. So the probability of a red plus the probability of drawing a blue is equal to, so P of R is 2 out of 7 plus P of B is 2 out of 7, which is 4/7. That's it for now.